Okay, so good morning, everyone. First comment that I'd like to make is that testing is now well underway in the online format in a little bit different model for the math team. So as I mentioned in my email, when you are ready for a test, when all the marking is done, I'll send you a quick email. I'll assign you a test time. If that test time really doesn't work, then you just tell me it doesn't work. We figure out, it has to be kind of a legitimate reason. And generally what I'll do is this, just so you kind of know my thoughts. I usually try to get marking done by the end of the week, by Friday, and I'll be assigning you a Tuesday, Wednesday, Thursday test time. Let's say like today I'm going to mark, it's a Tuesday. If I assign you a Thursday test time, you do have the right to say, hey, Ms. Fat News, and that's only 2 days. I'm not feeling comfortable enough. So that's okay. We will work that out. But we have great capacity now to get you in to take your tests fairly quickly, like not too quickly, but you're not waiting forever. So that's kind of the thought on tests. I'm feeling so much more settled and happy that we're able to offer you, I think, a better program because the tests are now happening in a timely manner. So that was kind of the first thing. Now our focus today is going to be on radicals, and there is a ton of material in the radicals unit. We'll see, how much of it we can approach today without totally overloading your brains. So to start with, I'm going to give you a little terminology, and we'll mess around a little bit with radicals, and then we'll try to do the 4 operations: adding, subtracting, multiplying, dividing. I don't really feel like I'll get to radical equations, but I'll try to give you a really good base of the radicals. So to start with, a little bit of terminology. If I give you something like the cube root of 35 squared, I'm not going to actually do anything with it. I'm just going to outline some of the terms. This is called the order or the index. The 35, well, let's put the squared kind of down in with the 35. The 35 squared is called the radicand. The whole thing is called a radical. Okay. I don't think there's any other terms we need to know beside order, index, and radicand. So if I'm referring to those terms, you'll know what I'm talking about. And there are 2 ways we write radicals. We write them in entire form, entire radical form. And that would look like something like the square root of, say, 45 x cubed y squared. That would be something that would be entire radical form. And then mixed radical form is where we would have something out front. And so it might look like this: 2xy times the cube root of 2xy. Okay, so if we want, again, a little bit more notes here. So here, everything is part of the radicand. And here we have a numerical, or actually not necessarily a numerical coefficient. We'll say a coefficient because there's letters there. We have a coefficient out front. And a radicand. Okay, and normally mixed radical form is considered simplest form. So when it says, multiply and simplify, this is what we consider to be the simplest form. Lowest radicand and in mixed radical form. Okay, so the first thing we need to do is start to develop being comfortable moving from form to form. Once we sort of got that under our hat, then we're going to go and move to the operations, okay, because it all flows from being comfortable here. So I put these examples here so we can actually flow through and do them. So question number 1 is change to mixed radical form. Lowest terms, and I'm going to take the one that I have here, root 45 x cubed y squared, we're going to start with that question. Okay. So something you of from former years, prime factoring. And it depends on how your teachers in the past showed you prime factoring. A lot of people do the factor trees. I have a slightly different way that takes up a little bit less room that I'll show you. You do it however you like to do it. So I usually do it over in my left-hand column. I kind of ran out of room there. So I'm going to do it on the right-hand side. But I take my numerical coefficient, the 45. And instead of doing it like this, I don't do it like that because I find it takes up too much room. I do an upside down division sign. And then if I'm doing prime factoring, so just to remind you what I'm doing is prime factoring. You have to know prime factors, and we assume in grade 11 you do. But let me outline. They're 2, 3, 5, 7, 11, etc. Usually you don't have to go past 2, 3, 5. So we're trying to break our number into prime factors. So we start by dividing by 2 if we can. Here, this doesn't divide by 2. So we divide by 3 and we get 15 out. So I put what I divide by in the front and what I get on the bottom. And then I just keep dividing by 3s until I can't anymore. And then as soon as the bottom number is a prime number, we're done. We're fully factored. Okay. Now what we do with that is we go back into the question, and instead of having 45, we write 3 times 3 times 5 in its place. And because this is the first question I'm showing you, I'm now going to write x cubed as x times x times x. And I'm going to write y squared as y times y. So it's going to be x times x times x and times y times y. So all I'm doing is expanding everything out so that everything is written like term to term. And the reason I show you this is because now the process I'm going to show you is super slick. We're doing a square root question. Square root questions mean find 2 things inside and take one of them out. Okay, so I circle all the pairs. Since I'm doing square root, there's a pair of 3s, there's a pair of x's, and there's a pair of y's. And square root indicates you want one of each of them. So we're going to take a 3 out, we're going to take an x out, we're going to take a y out. So out front, we're going to have 3xy. Then we're going to open up our radical sign. And anything that is not circled is now cycling back into our radical sign, 5x. And that is simplest form. Okay. So there's our answer in simplest form. Let's put a little red box around it. Whoops. Let me just make sure it's not right on top of my square root sign there. Like so. Okay, I'll pause the recording for a second. So if anyone has any questions, I'm not going too quickly. Okay, so the second thing to do then is if we're given something in mixed radical form, let's figure out how we put it back into entire form. So question number 2 that we're going to go after is going to read change to entire radical form. And I'm going to use the example that I had over here because it's a cube root example. We usually don't get too many examples that aren't square root or cube roots. You can have 4th roots and 5th roots. You will see it. We are in 20-1, but we don't see it too often. Okay, so now think about what we just did for a square root question. We were looking for pairs of things inside and we were taking one of them out. But this is a cube root question. So the numbers that arrived out front were inside as groups of 3. So when we go to change this back to an entire radical, the 2xy is still there. And I'm just going to do some color coding. Okay, so I'm just going to underline this 2. And then here I'm going to say, okay, we're putting that back in as 2 times 2 times 2. There's one of them outside. The only way that we had one outside is we had 3 inside. And then here, this x goes back in as x times x times x. And then again, I can just pick one more color. Let's see, pick the kind of the, let's see, yellow maybe. And so the y goes in as y times y times y. So whatever is out front, the only way it got out front was having 3 of them inside. And now we just kind of collect everything out. Okay, so we got 2 times 2 times 2 times 2. We got 4 2s. That multiplies to be 16. Count up the number of x's. We've got x to the 4th. And count up the number of y's. We've got y to the 4th. Okay, so we can make our radical a little smaller there. There's our answer. Okay, and again, if we're working with higher orders, all you do is put that number of items back inside. So it's a 4th root, you've got something outside, you put in 4 times. It's a 5th root, something outside, you put in 5 times. Okay, so that's the idea of moving from entire radicals to mixed radicals. Again, I'll pause for a moment, see if there's any questions. Okay, so now we're going to go and do operations. Now we've kind of got our base idea of how to move things around from mixed to entire. Now we're going to do adding and subtracting. And of course, I'll try to start with a fairly simplistic one and then move you up the ranks. Okay, I'll probably have to go and steal some questions from lesson quizzes or whatnot. Okay. So adding, subtracting radicals is like adding, subtracting in algebra. If I asked you to do an algebra question from grade 10, and I asked you to go 2x plus 3y, you'd go, well, there's nothing to do there. X's and Y's, they're not the same. But if I said, well, can you add 2x and 3x, you would hopefully recognize from grade 10 that you can add and get 5x. Right? If the letter or variable component is the same, you add the coefficients, add or subtract the coefficients, and keep the variable component the same. So those rules are exactly the same for radicals. Okay, so if I then go to a radical question, again, just leading you in to something nice and easy. If I have 2 root 2 plus 3 root 2, you can see it's kind of similar to the algebra question above. You leave the radical part the same because it's identical, and you write 5 root 2. Okay. And I'm just going to pause for just a second. Okay, so basically the rules here for adding and subtracting radicals are you have to have the same radicand, and then you add and subtract the coefficients out front. Okay, so the general rule here is we need the same radicand, then we add or subtract coefficients, and leave the radicand the same. All right, perfect. So let's get into something that's a little tougher and see how this goes. I'll be able to make up probably 1, and then I'll probably have to go and snag some from the lesson quizzes so that they will work out to be something reasonable and logical. Okay, so example, add or subtract. And the question is going to be, let me write it down on a piece of paper so that I know it's going to work. Okay, so this is a nice lead in. I don't think there's anything too extraordinarily difficult about this. So I'm just keeping it in square roots right now. We'll jump into a cube root question in a second. So it says 2 times the square root of 18, take away 3 times the square root of 50. Okay, if there's no little order index in there, we assume that it's a square root. So I'm going to give you some tips, then I'm going to just be quiet for a moment and give you a chance to see. I know it's the first example that we've had to do anything with, but see how well you can move along. So the tip is that you take 18 and 50 over to your margin. That's where I usually do it. And you prime factor them. Then you put them back in and you do the procedure I showed you about grouping them in groups of 2 and taking 1 out, and you try to simplify. See if you can get the same radicand, and then you can add or subtract. So I'll give you a shot at it. It'll give me a chance to go look at another question on a lesson quiz, and then I'll come back on the audio. Okay, so let's have a look at this. So I sent you off to do your prime factoring in your margins. So let's do that. So start by dividing by 2. We get a 9. We divide by a 3 and get a 3. So we got 2 times 3 times 3. The 50, again, start dividing by the 2. And then we get 25 out. And then we get 5 in because 3 doesn't go in and a 5 out. Okay, let's put that all back into the question. So we get 2 times the square root of 2 times 3 minus 3 times the square root of 2 times 5. All right, change the color up. There's our pairs. So we're able to take here a 3 out and just have root 2 left. Here we're able to take a 5 out and just leave the 2 in the back. Multiply the numbers out front. 6 root 2, take away 15 root 2. Okay, so really all we've done so far is the changing to lowest mixed radical form. We haven't done the adding and subtracting. Here's a subtraction question. 6 take away 15 is minus 9, and we leave the radical sitting there. And so the answer is minus 9 root 2, which a variety of you guys sent in before I started blasting off into it. Okay. All right. So I have one more adding subtraction question, and then we'll move on to multiplication and division, because then we can kind of smush them all together and do a few at the end that kind of have all the operations. All right. Fun times. Okay. So move that over there in case you're still writing. It's still on the board. Okay. So again, add or subtract. And made this one up on the fly, so hopefully it's going to work. 4x times the cube root of 3xy plus 2 times the cube root of 24x to the 4th y. And I'm hoping that's going to work. So I'll go off the recording again and give you guys a chance to give it a shot. Okay, let's have a look at how this goes. So the only one we have to prime factor is 24. So let's take it over to our margin, or over to the left-hand side. Put a 2 in, get a 12 out. Put a 2 in, get a 6 out. Put a 2 in, get a 3 out. All right, so there's our prime factoring. So we're really not doing much with the first term except carrying it along through the question. But the second term, we're going to break it all out. 2 times 2 times 2 times 3 and 4 x's. And we can graduate from this method if we get lots of letters, but because it's kind of the first time I've shown you any radicals, I'm just going to stay with the same method. Since it's a cube root question, I'm going to circle groups of 3. There's my 2 groups of 3. Again, the first term is just sitting here. Not doing anything but carrying into the question. Now we take a 2 out and we take an x out. Open the cube root and write what's left. So there's where the hitch is. I have to make sure that I design the question so we get like radicals, right? Because if we don't, we're in trouble. And so we get 4x times the cube root of 3xy, and then plus 4x. They're identical terms. I don't know that I specifically was trying for that, but anyway. Now, adding. So we know, hopefully we know now that it should be the cube root of 3xy. That part's going to stay the same. It's the identical radical. It just is written down. We just have to remember, back to algebra now. It's 4x plus 4x. It's 8x, not 8x squared. I got 8x squared from a few people. It's just 8x. So the answer in front here is that. So there's the answer. All righty, perfect. Okay, so the next thing on our agenda then is to do multiplying radicals. And again, if we go back and think about algebra, the rules of algebra apply to radicals. So just a little tip, a little reminder, if I have 2x times 3x, 2 times 3 is 6, and x times x is x squared. Or if we had something like 2x times 3y, 2 times 3 is 6, and the x's and y's just go x times y. Okay, So that helps a little bit. I mean, it gets a little bit more complicated with multiplying radicals, that's for sure. Okay, so let's blast off into one. Okay, so it will say to us to multiply and simplify. And again, just a reminder, simplify means lowest mixed radical form. So leave the, the least amount you possibly can, leave it in the radicand. Okay, just reorganize my screen just a little bit there. Okay, so we'll lead out with something. We won't make it too hard. 4 times the square root of 12 multiplied by 5 times the square root of 6. Nothing too big. So in terms of rules, it's radicand times radicand and coefficient times coefficient. So I'll lead you through since this is the first one. So we get 20, and then, so 4 times 5 is 20. Now, a thought for you. Instead of multiplying 12 times 6 and getting 72, and then taking 72 over to the side and doing the prime factoring, it would be less work if we did it this way. And it's just a thought. We could just multiply these in one radicand as 12 times 6. And I'm pretty sure you guys are pretty smart as a whip kind of children. So I bet you could do this without having to go over and do your prime factoring. But if you do, the numbers just stay smaller. So you get 2 into 12 gives you 6, 2 into 6 gives you 3, and then you have another 6 to do, it's 2 and 3. So you can do it that way, or you can make it 72 and do it that way, it doesn't matter. So now we rewrite this all together. So 12 is 2 times 2 times 3, and 6 is 2 times 3. All right, the only maybe you don't love is the fact that the pair of 3s are not beside each other, but I bet we can adjust. So there's one pair we're going to take out, and there's the other pair we're going to take out. And so then we get 20 times the square root, oops, sorry, got to take the numbers out. 20 times the 2 times the 3, and then one little poor 3 left inside. And then we get 40 times 3, 120, I think. Hopefully that's right. And there we are. Okay, and of course I'm not mix and matching with all bunch of letters yet. That'll come. Trust me, that will come. Okay, and I made a little copying error. Thank you guys. It's a 2 that's left over. If I just circle the 2 just to show you my little error here. Whoops, that shouldn't be a 3. Thank you very much. Yeah, sometimes when I'm talking and writing it, easy to make those copying errors. Thank you very much. Excellent. Okay, so there's our answer. Okay, so before we get too many letters and whatnot flying around in here, I think we should probably do a few more little operational things. Yes, sorry, I confused the heck out of you. A few more little operational things just to remind you about some algebra that I know you guys know and how it would work in with the radicals. And it'll give me the opportunity to introduce something called conjugates. All right, so we haven't done any division yet. Which is okay, we're going to get there. But let's do a second multiplication question. Multiply and simplify. And I'm picking it specifically for, you'll see why I'm picking it. Okay, so we're going to get the root of 2 plus the root of 3 times the root of 2 minus the root of 3. And before I go any further, I'm just going to introduce the idea of conjugates. I don't know if you guys would have had a teacher along the way ever talk about what conjugates are. It could have come up in grade 10 when you were factoring as a difference of squares, but you know what, when I teach grade 10, I don't think I actually call them conjugates. So can you guys see what's similar about these two brackets? They're almost the same, except one has a plus sign and one has a minus sign. That's the definition of conjugate binomials, okay? Same terms, different signs, all right? So let's make a little definition here. Conjugate radicals. Same terms, different signs. And something really cool happens, and we'll need to use conjugates when we get to division. So it's a nice way of introducing it to you right here. So remember, I'll just rewrite it down here so that I can draw on the question. So I'm not doing anything but just rewriting it. Remember the word FOIL. I'm sure you guys, we're halfway through the course. We've done lots of FOIL questions. So we get root 2 times root 2. And I'm going to write it as root 4. I'm going to actually do the multiplication. And then we get root 2 times minus root 3. So minus root 6. Root 3 times root 2 is plus root 6. And root 3 times minus root 3 is minus root 9. Now something really cool happens here. The minus root 6 and the plus root 6 cancel. And the numbers that we have left over are perfect squares. So the square root of 4, we don't have to do any work to that. I think you guys would be capable of just writing 2. And the square root of 9 is just 3. And then 2 minus 3 is minus 1. This is something super cool with conjugates. When you multiply them, you always have all the radicals go away and you get some sort of number. Okay, so you might want to note that. Okay, you always have the radicals cancel for conjugates. Okay. Questions? I'll pause again for a moment. Okay, so the last operation is division. It's kind of, I can think of kind of 3 things I need to point out to you. One would be if we can divide, we just go ahead and divide. So if it divides nicely, I'll just say go for it. It goes just to the same thing as multiplication. So that's one thing that can happen. We can get a real nice question. Second thing that can happen is we can have a radical in the denominator that we can't easily simplify. So we have to do something. So we have to rationalize the denominator, which is, I'm going to show you how to do that. Sounds kind of complicated. Trust me, you have to do harder things in the course than this. Denominator, okay. And the third thing that can happen is you can have a binomial radical in the denominator. So we multiply by, wait for it, the conjugate. Okay, so those 3 things, just don't need them, are how we're going to attack the next 3 questions. So I'm going to give you a nice, easy, easy quote, 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 one to do. Then we'll look at one where there's a radical in the denominator and we have to do what's called rationalize the denominator. And then we'll look at one where we have a binomial radical in the denominator. We have to do the conjugate, and then we'll just open it up and then we can blast off and do tough ones. I know you're really looking forward to that. Okay, so example 1. Divide and simplify. Okay, so let's do 2xy times the cube root of 16 x to the 4th y to the 3rd over xy times the cube root of 2xy. Okay, that looks horrible. I really cranked it up, but I actually really kind of didn't. Because if you step back for a second and you look at it, we've got some coefficients that nicely divide. And we've got a cube root in the top and a cube root in the bottom, and they just nicely divide. So long as you remember your exponent rules, you're all good. So let's go see how this goes. So this x and this x cancel. X divided by x cancels. Y divided by y cancels. So all we have left in front is 2 at the moment. We may end up having more than that. Then we divide. So we are able to, in this question, I've set it up. So 16 divided by 2 is 8. X to the 4th divided by x is x cubed. Remember, hopefully you remember, you subtract the exponents. And then here we subtract the exponents, we get y to the second. So again, let me just recap. Going back, the x cancels with the x, the y cancels with the y, leaves us just a 2 out front for the moment. Then in the radicands, we open up a cube root. 16 divided by 2 is 8. X to the fourth divided by x, we subtract the exponents and get x to the third, and y to the third divided by y to the first, we subtract those exponents, get y squared. Okay, now we look at simplifying. So there is a little bit more simplifying that has to happen here. And again, I see lots of us just motoring along. You're probably ahead of me. You multiply the 8 out into 2 times 2 times 2. If you don't know that that's what it is, you go over to the side and you do your prime factoring. And then x times x times x, and then y times y. And I know I'm showing it this way, but it's just so nice. You get into a routine here. Routine is good. And then we're able to take out a 2 and an x. The poor little y squareds are stuck inside, so we're going to have the square root of y squared there. And the final answer would be 4x times the cube root of y squared. Okay, so have a little look at that. I'll pause again and give you a chance to ask any questions. All righty, so now we're going to go into the second option I had was if we have a radical in the denominator, we have to do something called rationalizing the denominator. So our directions are going to be exactly the same. Example 2, divide and simplify. Something I should note for you. Mathematicians have all these rules, and one of the rules is you cannot leave a radical in the denominator. Get ornery about that. Okay, so we're going to look at how do we deal with that if we have one left in there. And I'm going to lead in with a fairly easy question. I'm not going to do anything too wild and wacky. So let's say that we have something like 2 over root 3. That's something kind of real easy. I would hope that's really easy. Okay, so there's nothing to divide. There's no radical on the top and radical on the bottom. There's no coefficient on the top, coefficient on the bottom. Now you need to learn about rationalizing the denominator. Rationalizing the denominator just means that we're going to try to get rid of that radical on the bottom. Now you might remember throughout your math career that what you do to the top, you do to the bottom. Just like equations, what you do to the left side, you do to the right side. So we're going to multiply the top by root 3 and the bottom by root 3. We're allowed to do this because this is just the number 1, right? Root 3 over root 3 is just the number 1. And then we multiply. So we get 2 root 3 over root 9. Hey, cool. Root 9 is 3. You get 2 root 3 over 3. Mathematicians, we like that much better. Don't really know why we stand on ceremony, but that is the way we would want that answer to be, as we would want to look at leaving the denominator as a rational number, not an irrational number. Okay. And then the third type of example that I had noted. So again, it's still divide and simplify. But I'm going to give something like root 3 plus root 5 over root 7 minus root 2. Okay, so I've got some adding and I got some dividing in there. Just be careful your order of operations. You can't divide top and bottom individually. You have to do them as a group. And there's nothing really that divides here. So this is where we're going to multiply by the conjugate. Remember what the conjugate was? It's the same exact expression with a positive or the same exact expression with a negative, different sign. Which one does anyone want to jump in? Are we going to multiply by root 3 minus root 5? Or are we going to multiply by root 7 plus root 2? What do you think? Because I can do a conjugate at the top and I can do a conjugate at the bottom. Which one do you think is what we would want to do in radicals, thinking about the fact that we don't want radicals in the denominator? Anyone want to take a chance? You could come into the chat bubble, or you could come on the audio and be part of the recording, so it wasn't just all Mr. Van Dusen. Correct, the bottom. Thank you very much for that interjection. So we're going to multiply the top by root 7 plus root 2 and the bottom by root 7 plus root 2. Remember, what you do to the top, you do to the bottom. Keeps everything nice and equal. Now, because these are binomials, we better be cautious. Put some brackets around some things. And now you got a whole bunch of nice FOIL to do on the top and the bottom. So I will pause the recording, give you a chance to take a shot at that. Okay, I know you're working away. I'm just gonna be quiet and I'll write some things on the board. I won't chat and then I'll go through it. Okay, so I'll chit chat about it now. So we're just doing FOIL. I get the impression that FOIL's not causing anyone any trouble. So root 3 times root 7 gives you root 21. Root 3 times root 2 gives you root 6. Root 5 times root 7 gives you root 35. And root 5 times root 2 is root 10. And then we just repeat the same thing on the bottom. Root 7 times root 7 is the root 49. This is where the neat stuff's going to happen. So these guys here give us root 49. And then root 7 times root 2 gives us plus root 14. Root 2 times root 7 with the minus gives us minus root 14. And minus root 2 times root 2 gives us minus root 4. So not a whole bunch to do on the top. 21 is 3 times 7. There's nothing. I don't think we can take anything out. If we factor all those 4 numbers, we have no pairs. So I give you kind of a wacky one. The numerator is the numerator. So we're going to have to just write it down. Root 21 plus root 6 plus root 35 plus root 10. I could have done something a bit better up there, but oh well, doing it on the fly. Down here is where the cool stuff happens, right? 14 and 14 cancel. Root 49 is 7. Root 4 is 2. And so we get our final answer of root 21 plus root 6 plus root 35 plus root 10. Kind of awful up there, all over 5. And this makes us happy as mathematicians because we've got the denominator as a radical number, or a rational number, sorry, a rational number, not an irrational number, not a radical. Okay, so we have now covered adding. We did mixed into entire, back and forth. We did adding and subtracting. We did multiplying, and we've done dividing. We've done kind of the base of everything. All right, so I'm going to go look at Module 5, Lesson 2 and 3, and I'm going to grab some of the uglier ones and see what we can do on them. Now I have to move back here and do some. Let's see. I got some clear board here. Perfect. All right. So try to pick a real lovely one. Oh, here's one. Okay, so I'm just going to write it down here so I can get it. Oh, that one's not even that hard. It looks hard, not even that hard. I'll do this one. Okay, so this one is maybe a little tougher. All right, here it comes. So simplify fully. This is from Module 5, Lesson 2 quiz. I know some of you have done it, some of you haven't. That's okay. So 7 root 7 minus 6 root 2, take away bracket 4 root 28 plus 4 root 3. I think was the question. No, maybe not. Let me just go double check it before we blast off in it. Oh yeah, I think that's right. 7 root 7 minus 6 root 2 plus 4 root 28 plus 4 root 3. All right, rock and roll. Careful of the brackets, careful of the subtraction sign. See what you can do with it. And then I'll come back on the audio in a second. Okay, I'll try to catch up a little bit here. probably the first thing to be cautious of is this subtraction sign out here. Now, I personally would get rid of it by going minus 4 root 28 minus 4 root 3. That would be my first thing. You might attack the radical part first. Now, the only radical that we have to do any work on is the 28. So put 2 in, 14 out, 2 in, 7 out. Good. And you may get quicker at simplifying the radicals than the work I'm showing, because it gets a little bit tiresome to have to write everything, but nonetheless, trying to keep it so that it's not so bad. So we get 7 root 7 minus 6 root 2. And then these guys come out. And I think we're okay. Can I write that as an 8, right? 4 times 2 minus 4 root 3. I don't know, maybe the initial question should have had a root 3 here, so we get some more things combining. But anyway, these two are the only thing that can combine. So we get minus 1 root 7 minus 6 root 2 minus 4 root 3. So I think I might have copied it not quite exactly the same from the quiz. I think that should have been a 3, and we could have put some more things together, but nonetheless. Okay, so really what you have to watch here is distributing the negative, simplifying the one radical, and making sure that that one's the one that combines and the other guys just kind of hang out. Now, I know some of you might see that there's a negative in each of them, and so it might be worthwhile. I wouldn't certainly take marks off, but I know you're always looking out for things, so you could write it this way as well, just if you thought that the negative was nicer to be out front. Okay. Now, at the beginning of the class, I had asked you if you had any that you wanted help on, and I had an equation passed to me. Now, I wasn't going to really talk about equations, and we're getting a little bit long, but why don't I just give kind of the real quick, short and curly of equations for radicals, okay, so that it's sort of complete. So here's the rules and regulations for radical equations. And then I'll do the one that I was referred, and then we'll wrap it up. It's getting a little bit long. Okay, so step number 1 in radical equations is that we want to isolate the radical. Okay, we all know about isolation with COVID going on, right? Isolate means be by yourself. So we're going to make sure that the radical is by itself as best we can. And then we're going to square both sides. And then we're going to solve. Okay, there are 2 things that can happen when you solve. If it's a linear equation, you just kind of solve normally. And if it's a quadratic equation, you equal to 0 and factor. And that's something hopefully you guys are getting to feel a little bit more settled with. And then the 4th thing you have to be cautious of is you have to verify, because sometimes we have something called extraneous roots. And extraneous roots, just look at the root of the word extraneous, means extra. Sometimes when you square both sides, you cause extra values to come that don't actually work. Okay, so just have to be cautious about that. So I'm going to go and grab the question that I was asked about, just to do one radical equation. So we've got that, and then we'll wrap it up. Okay, so where is it here? Just give me a second, just so I copy it down exactly correctly and don't make any mistakes on it. Okay, so question is, okay, so yeah, good thing I wrote it. Now I have it, so I'll write it on my piece of paper and get it down correctly. Okay, so, oops. All right, here we are. Okay, so the question, this comes from the Module 5, Lesson 4 quiz. 2 times the square root of x over minus 9 equals the square root of 68. That's a really wacky question. Now, the first thing I said there was to isolate the radical. This one happens to have 2 radicals, maybe not the best question to do as my first lead in, but nonetheless, we've got root 68 by itself. So that's isolated enough. So second step says square both sides. So let's put this in brackets and square it, and this in brackets and square it. So be cautious when you're squaring this. You square the 2 out in front, you get 4. And this square just cancels the square root. So you get x over minus 9. On the right-hand side, the square and the square root just cancel and you get 68. So what looked like something really awful is not quite as awful. We could multiply and get 4x over minus 9 equals 68. And then I think the way I would think about it is I'd put this over when I cross multiply. So I'd get 4x equals 68 divided by 4. 68 times 9. Let's do what I'm supposed to do here. So we're cross multiplying. So we get minus 612, I think. 16, yeah. And then divide both sides by 4. And we get a negative answer of negative 153. Now, pretty odd that we get a negative answer for a radical question, but we have a negative 9 underneath the radicand up top. So here's what a verification looks like. Okay, so you write the original question. Always go back to the original question, the original equation. Don't go part way down or anything. Now, I'm going to show you something that I will not enforce in Math 20-1, but I really will enforce in 30-1. So if you happen to be taking 30-1 with me and with anyone, this is something that you might as well learn. When you're verifying and you're not sure if one side actually truly equals the other, the right formatting is to put a line down the middle. Do all the work on the left-hand side, do any work that might be on the right-hand side, and make sure you get the same answer, okay? So I'm going to model that for you. So I'm going to get 2. And then I'm going to put the answer in, minus 153 over minus 9. And then no equal sign, just root 68. So we're going to try to make sure we can get both sides to be the same. So what's 153 divided by 9? 17. Okay. So we get 2 root 17 and root 68. So I think the best way is now to look at the right-hand side, take 68 and do some factoring. So you take 68 over to your column, wherever you're going to do your factoring, and do some factoring until you get it broken down. So 68 divided by 2 gives you 34. Take another 2 in, you get 17. So not too hard. Looks like an awful number, but it's not terrible. And so then we simplify this side, we get 2 times 2 times 17. There's our pair, 2 root 17. Good. Now we know we are okay. Then we can put the equal sign. Now I'm not gonna enforce the whole vertical line and whatnot, but that is kind of the correct way of showing verification. You can just work it through and just make sure you get the same thing on both sides. Okay, so 0 to 100 there, we did pretty much the whole radicals unit today. Maybe not all the difficult questions, but hopefully trying to give you an overview.